Hi everyone, I am Arun JULKA. Today in Properties of Determinants Part 3, we will discuss some more problems of determinants. Example 1. Expand using properties of determinants. First column is A, 2A, 3A. Second column A plus B, 3A plus 2B, 6A plus 3B. Third column A plus B plus C, 4A plus 3B plus 2C and 10A plus 6B plus 3C. In this example, if you see the first column, A is common. So take A common from the first column and we will get A as common. In the first column 1, 2, 3 and the second and the third column remain same. Now we have 1, 2, 3 in the first column. We will make it 100 using property R2 equals to R2 minus twice of R1 and R3 equals to R3 minus thrice of R1. So first row remains same. In second row we will get 0, A, 2A plus B. In third row we will get 0, 3A, 7 plus 3B. Now we will use the operation R3 equals to R3 minus thrice of R2. First two rows remain same. In the third row we will get 0, 0, A. And the answer is A into A square, which equals to A cube. Next example. Expand using properties of determinants x, y, x plus y, x plus y, x plus y, x and y. First we use operation C1 equal to C1 plus C2 plus C3. So the first column will become twice of x plus y, twice of x plus y, twice of x plus y. And the second and the third column remain same. Now we will take twice of x plus y common from the first column, and the first column we have 1, 1, 1 and the second and the third column remain same. Now we will use the property R2 equals to R2 minus R1 and R3 equals to R3 minus R1 to make triple 1 equals to 100. So first row remains same. In the second row we will get 0x minus y, third row 0x minus y and x. Now expand along first row and we will get twice of x plus y whole multiplied by x square minus xy plus y square, which equals to twice of x cube plus y cube. Next example. Expand using properties of determinants a square bc ac plus c square, a square plus ab, b square ac, ab, b square plus bc and c square. First we take common A, B and C from first, second and third column respectively, and we will get A common. In the first column we will get A plus B, B. In second column we will take common B and we will get C, B and B plus C. In the third column we will take C common and we will get A plus C, A and C. Now use property R1 equals to R1 minus R2 plus R3. Second and third row remain same. And the first will get minus 2b and 0. Take minus 2b common from the first row and now make double 1 equals to 10. Using property C2 equals C2 minus C1, the first column remains same. In the second column we will get 0 minus a c. Third column is 0 a and c. And after expanding we will get 4a square b square c square. Next example. Prove that A, B, C, X, Y, Z, Y, Z, Z, X, X, Y equals to column wise AX, BY, CZ, X square, Y square, Z square, 1, 1, 1. First we take left hand side, which equals to row wise ABC, X, Y, Z, Y, Z, Z, X and X, Y. First we take transpose. We know that transpose determinant always be equals to determinants. Now multiply first, second and third row by x, y and z respectively. When we multiply first row by x, we will get ax, x square, x, y, z and divide by x. Second row multiply by by, y square, x, y, z and whole divide by y. Third row multiply by z, cz, z square, x, y, z and whole divide by z. Now take x, y, z common from the third column and we will get x, y, z common. First two column remain same. In the third column we will get 1, 1, 1. So this is equals to right hand side. Hence proved. Next example. Expand using properties of determinants where first column xyz, second column x square, y square, z square, third column yz, zx and xy. Multiply row 1, 2 and 3 by x, y and z respectively. So we will get in the first row x square, x cube, xyz and whole divided by x, y square, y cube, xyz in the second row and whole divided by y. Third row z square, z cube, xyz and the whole divided by z. Now we take xyz common. The first two columns remain same. In the third column we will get 1, 1, 1. Whenever we have triple 1, we always make it 100 using operation R2 equals to R2 minus R1 and R3 equals to R3 minus R1. So the first row remains same. In the second row we will get y square minus x square, y cube minus x cube and 0. In third row z square minus x square, z cube minus x cube and 0. Now we will take common y minus x from the second row and we will get in the second row y plus x, y square plus x square plus xy 0. In the third row we will take z minus x common. Third row z plus x, z square plus x square plus zx and 0. And the first row remains same. Now we will use the operation R3 equals to R3 minus R2 to take one more factor common. So first row remains same, in the second row remains same, and in the third row we'll get z minus y, z square minus y square plus x times of z minus y and 0. And now we'll take z minus y common from the third row. First two row remains same, in the third row we'll get 1, z plus y plus x and 0. Now expand along first row and we will get, after simplification, x minus y, y minus z, z minus x multiplied by yz plus y square plus xy plus xz plus xy plus x square minus y square minus x square minus xy. Xy and y square cancel by x square and y square, xy cancel by xy, and we will get x minus y, y minus z, z minus x multiplied by xy, y plus z plus zx. Next example. If a plus b plus c not equal to 0 and determinants of abc, bca and cab equal to 0, then prove that a equals to b equals to c. It is given that determinants of a, b, c, b, c, a and c, a, b equal to 0. So first use operation c1 equal to c1 plus c2 plus c3. In the first column we will get a plus b plus c, a plus b plus c, a plus b plus c, and the remaining two columns remain same, which equals to 0. And now we will take common a plus b plus c from the first column and we will get 1, 1, 1, and the second and the third column remain same. Whenever we have triple 1, we always make 100 using operation R2 replaced by R2 minus R1 and R3 replaced by R3 minus R1, and we will get a plus b plus c is common. The first row remains same. In the second row we will get 0, c minus b, a minus c. Third row 0, a minus b and b minus c, which equals to 0. Now expand along first row and we will get c minus b multiplied by b minus c minus a minus b multiplied by a minus c, and which is whole multiplied by a plus b plus c, which equals to 0. And after simplification we will get a plus b plus c whole multiplied by cb minus c square minus b square plus bc minus a square plus ac plus ba minus bc, which equals to 0. And after simplification we will get minus common a plus b plus c whole multiplied by a square plus b square plus c square minus ab minus bc minus ca equal to 0. And now whole multiplied by 2 and divide by 2. So we take 1 by 2 common and 2 multiply inside. We will get 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca equals to 0, which equals to minus half a plus b plus c whole multiplied by a minus b whole square plus b minus c whole square plus c minus a whole square, which equals 0. It is given that a plus b plus c not equal to 0. So a minus b whole square plus b minus c whole square plus c minus a whole square equal to 0. This implies a minus b equal to 0, b minus c equal to 0 and c minus a equal to 0 and a equal to b equal to c. Hence proved. Last example. If pth, qth and rth term of a GP are a, b and c respectively, then prove that determinants of log a, log b, log c, p, q, r 1, 1, 1 equals to 0. In GP, the formula of nth term is a r to the power n minus 1. So p term is a r to the power p minus 1 which equals to a. Q term is a r to the power q minus 1 equals to b. And the r term is a r to the power r minus 1 which equals to c. Now we'll take left hand side and replace the value of a, b and c by a r to the power p minus 1, a r to the power q minus 1 and a r to the power r minus 1, and we'll get log a r to the power p minus 1 log a r to the power q minus 1 log a r to the power r minus 1 p q r 1 1 1. We know that log m into n is log m plus log n. So log a into r to the power p minus 1 equals to log a plus log r to the power p minus 1. Similarly, next is log a plus log r to the power q minus 1 and the next is log a plus log r to the power r minus 1. Second and the third column remain same. Now we break the first column, and when we break the first column it's log a, log a, log a, and the remaining two columns remain same, plus p minus 1 into log r, q minus 1 into log r minus 1 into log r, and the next two columns remain same. Now we'll take log a common from the first determinant and we'll get 1 1 1 pqr 1 1 1. From the next determinant we'll take log r common and we'll get p minus 1 q minus 1 r minus 1, and the next two columns remain same. Now we'll use operation c1 replaced by c1 plus c3. First determinant equal to 0. In the second determinant we'll get first column pqr and the second other two columns are remain same because c1 equals to c2, so the value determinant equal to 0.